Hello friends, in this lecture I use trapezoidal rule to find the numerical integration for a function. Okay. As we know, integration determines the sign of the area enclosed by a given function and the axis. It's no matter the x-axis or y-axis, but in this case, the area enclosed between the curve and the x-axis. The topic of numerical integration can be used to solve several problems. The first problem, maybe the function cannot be integrated. For example, we have this Gaussian curve. We cannot integrate the function, so the numerical integration is a good idea to find the approximate solution for the function. The second problem, when the data comes from the measurement. Let us solve the problem by trapezoidal rule. We have this function f(x) equal to 2 to the power x. We have to find the numerical integration by the trapezoidal rule. Okay. First, I want to analytically integrate the function and find the exact value for the area. Okay. By integration from -3 to 4 of 2 to the power x dx equal to 2x over ln 2 from x minus 3 to 4. If we plot 2x over ln 2, we get this curve. We see the curve. Let us evaluate the area. By put the boundaries 2 to the power 4 over ln 2 minus 2 to power minus 3 over ln 2, we get 22.9. That is the exact solution for area enclosed between the x-axis and the curve. Let us use trapezoidal rule to find numerical integration and find the area. Okay. That is the trapezoidal rule. Trapezoidal rule equal to h over 2 multiply the function of x naught plus 2 multiply intermediate y plus the function of xn. Xn is the last y value. Let's see. We have to divide the interval -3 and 0.4 into n equal parts of subintervals. I divide it to 10 subintervals. So we have 11 division points. That is the division point. And between division points, we have a subinterval. Okay. N equal to 10, A equal to -3, B equal to 4. Let's find the length of subintervals. Just replace the variable with the value b minus a over n equal to 4 minus -3 plus, over 10 equal to 0.7. 0.7 is the distance between division points or the length of subintervals. Okay. That is the result for exact solution. Let's find the numerical integration or find the area numerically. First, we have to create our division points in tabular form and calculate the corresponding function values. See, we have x values. How we get these values? We just put the lower boundary, which is -3, plus h, which is 0.7 equal to -2.3, and then plus h equal to -1.6 plus h, which is 0.7 equal to -0.9, and so on till you get the upper boundary, which is 4. So let us evaluate the function of x at these division points. Put -3 into the function, so f(x) equal to 2 to the power -3, it's equal to 0.125, and 2 to the power -2.3 equal to 0.2031, and so on. Let us plot the y values according to x, respect to x. You see that curve is the result of the y value, which we found it. Just plot f(x) and x, you get this curve. Okay, that is the trapezoidal rule. Just replace the value with the symbols we have. Let's evaluate the area by trapezoidal. Okay, it equal to 0.7 over 2, and just put the first y value, which is 0.125, and 2 multiply these intermediate y values. Just to multiply the summation of these intermediate y values and plus the last y value for xn. Okay, let's simplify more. 0.7 divided by 2 equal to 0.35, or put 0.125 as it is. Then 2 multiply the summation of y intermediate y value equal to 25.295 plus 16. The result is 23.35. Okay. In the next video, I talk about the types of error by trapezoidal rule. For today, that's all. I hope it can be helpful. Have a nice time.